Okay, in the previous section, we were talking about trigonometric functions of acute angles. We always assumed that the angle we were given was an angle in a right triangle, an acute angle in a right triangle. In this section, we want to talk about trigonometric functions of any angle. So we're not necessarily having an angle that's acute living inside of a right triangle. So the definition says, let xy be any point besides the origin on the terminal side of angle theta in standard position. Let's just focus on that first sentence. There's a lot of words there. So it mentions an angle in standard position. Okay, now we know what that is. That means the initial side of the angle is along the positive x-axis. Okay, that's standard position. And it mentions an angle theta in standard position. I'm just going to draw theta in the first quadrant. I could draw it anywhere, but I'm just going to put theta in the first quadrant. So there's my angle theta. And it says, let xy be any point on the terminal side of angle theta in standard position besides the origin. So I'm just going to say pick xy out here. Okay, so let me say the first sentence again. Let xy be any point besides the origin on the terminal side of angle theta in standard position. So the first sentence is just saying this. Okay? Now, let me make a triangle out of this. Now, I'm always going to draw triangles in this situation with a vertical line segment. Don't draw it horizontally or you're going to confuse the issue. So I'm going to draw a right triangle by going from the vertical side down. Okay? Now, so I mean, suppose the coordinates of this point were, 2, 3. Okay, 2, 3. Well, how far is it from here to here? Well, to plot the point, you go over x and up y, right? So that would be 2 and that would be 3. So this is x and this is y, right? You go over x and up y. And we're going to call the length of a hypotenuse here r. Now, it says in the notes, in the definition in the book, they tell you what r is, okay? But can't we figure out r? You don't have to memorize the formula, but it's a right triangle, so x squared plus y squared is r squared using Pythagorean theorem. So to solve for r, take the square root of both sides. R is the square root of x squared plus y squared. Now again, normally when you introduce a square root, you have to take the plus and the minus, but r is a distance here, so r is positive. Okay? And now I've added in the notes there, I put in parentheses, note, I said, so r is greater than 0. Now I know r is not negative, okay, but why can't r be 0 is what I'm noticing here. I know r is positive, but why can't r be 0? Well, remember what r is standing for here. R is the distance from the point xy that we chose on the terminal side to the origin. Remember, we specifically said the point cannot be the origin, so there has to be some positive distance between them. Okay, so that's why r is positive. R can't be 0 because this point is not the origin. Okay, so once we have this picture, we have x, y, and r. They mention the definitions of the 6 trig functions in this situation. So in the book, they're writing sine as y over r. I'm not going to list all of them because they're in your notes. Cosine is x over r. And tangent is y over x. So that's how they're listing them in the book. Now notice in the notes, I have added some extra words there because we've already learned trig functions for acute angles, right? So remember what in the previous section, what sine was. Sine was opposite over hypotenuse. If you apply that definition here and think of sine just like we did before as opposite over hypotenuse, what do you get? Y over r. So you don't have to rememorize the definitions in this section with x, y's, and r's. Just use the definition we had before. Sine is opposite over hypotenuse. That's y over r. Cosine was adjacent over hypotenuse. Notice that's x over r. So you can use the same definitions, that we covered in the previous section here. Notice tangent is y over x. That's what they said tangent is. But what did we say it was in the previous section? Opposite over adjacent. And notice you get y over x, right? Opposite over adjacent. Okay, so there's really nothing new here. If you can remember your right triangle trig, your definitions opposite, adjacent, hypotenuse, you've got your x, y's, and r's. Now, some of you may have had trig before, and you learned x, y's, and r's. That's fine. If you imagine this picture and you know that sine is y over r, just think that sine is y over r, that's opposite over hypotenuse, right? So you can translate between the two. If you know one of them, you can figure out the other one from thinking about this picture. Okay, let's do an example. So the example here says the terminal side of angle theta goes through the point negative 5, 8. Find the values of all 6 trig functions for theta. Okay, now where's negative 5, 8? Negative 5, 8 is in the second quadrant. You don't have to draw this to scale. You don't have to put all the tick marks. Negative 5, 8 is over here somewhere. Okay, initial side, the terminal side goes through that point. I don't know that that's a rotation for theta. I just like to put something in there. So I'm going to pretend theta does that. Okay, now I need to draw the picture, right? I need to complete the picture like I did in the definition. Draw your triangle, right triangle with a vertical line coming down from the point. And now let me label the sides. Now you have to be careful here. The way I drew the picture in the definition, I put the angle in the terminal side in the first quadrant. So x and y were both positive. Notice here x is negative. Now in the definitions here, they say, sine is y over r, cosine is x over r. It doesn't say that they have to be positive. It's not a distance. It's the x value and the y value. So just because of that, this is the point negative 5, 8. So it's x is negative 5 and y is 8. So I'm going to write negative 5 here. I'm not saying the length of this segment is negative 5. I'm saying the x value is negative 5. That's what I mean when I write that. Because if I don't put the negative 5 there, I may accidentally leave it off when I do my trig functions. Now, since we're doing all 6 trig functions, we need r. Remember, r was the square root of x squared plus y squared. Now, be careful here also. X is negative 5. When you square negative 5 times negative 5 is positive 25. And I can't tell you how many students will write negative 5 squared like that, type it in the calculator, and then they'll get negative 25. But what we want is negative 5 squared, which is positive 25. Remember, order of operations, they do the exponent first, then the negative. They mean this, and they write this, or type that in. So just to avoid that possibility of making that little mistake, ignore the negative. When you square, it's going to go away anyway. So just do 5 squared plus 8 squared. So then you don't accidentally type in the negative the wrong way. And so r is the square root of 25 plus 64. Which is a square root of 89. Now, it didn't say so here in the directions. Oftentimes, I will say give the exact value, or the book will say give the exact value. Remember, exact value means don't punch in the calculator around. Just leave that alone. So I'm going to put that in my picture, square root of 89. Well, we've got the 3 sides of the triangle. We got x, y, and r. We can do all 6 trig functions. Now, remember, you always label your work. Sine of the angle equals the number. Cosine of the angle equals the number, right? Don't put sin equals. You have to take sine of something. Tan of theta, cosecant theta, secant theta, cotan theta, right? You always label your answers. Trig function of the angle equals the number. Okay, now, notice here, my theta is not in the it's not an acute angle. It's not in the first quadrant. So again, we have to be a little careful. I am taking sine of this angle. But notice, there's no triangle involved with this angle theta. There's no opposite theta, okay? So if you're using your opposite adjacent hypotenuse definitions, we're taking sine of theta, but you use this little helper angle in the triangle. This angle right here, I'm taking sine of theta, but when I use opposite adjacent hypotenuse, I'm referring to the little angle here in the triangle, not the angle up here, the angle close to the origin, okay, so right here. So sine is y over r, or if you prefer, opposite over hypotenuse. It's not the side opposite theta, even though we're taking sine of theta. It's the side opposite the helping angle here. So opposite over hypotenuse, that's 8 over square root of 89. Again, you don't have to rationalize for me, but keep in mind, on the back of the book, or on an online computer package for homework, they're going to rationalize the denominator. Cosine, remember cosine in this section is x over r, or it's, again, using this angle, adjacent over hypotenuse. So minus 5 over square root of 89. Okay, now what about tangent? Tangent is y over x, or opposite over adjacent, minus 8/5. And you can get the other 3 by taking reciprocals. Sine and cosecant are reciprocals of one another. That's square root of 89 over 8. Secants are reciprocal of cosine. So it's minus the square root of 89 over 5. Remember, in a fraction, if you have a negative fraction, the negative can be in the numerator, the denominator, or out front. It doesn't matter where you put it. And cotangent's a reciprocal of tangent, it's minus 5/8. So there we go. So you can still use the definitions from the previous section, opposite, adjacent, hypotenuse, even though in 4.4 they're just doing x, y's, and r's when they're explaining things. But just use the triangle here. We're taking sine of this angle, but use opposite, adjacent, hypotenuse with the angle in the triangle next to the origin. Okay? No problem. Okay. So if we were in the third quadrant or the fourth quadrant, it'd be the same sort of thing. Use the angle in the triangle next to the origin. Now, the next thing is what I call my butterfly picture, even though the way I draw it doesn't really look like a butterfly. But, right? So if the terminal side of angle theta was in the first quadrant, like this, and you pick the point on the terminal side, and I say make a triangle with a vertical line. We just did one in the second quadrant. Pick the point on the terminal side, make a triangle with a vertical line. Third quadrant, vertical line. Fourth quadrant, vertical line. Okay? All right, so I'm interested in x, y's, and r's. Are they positive or negative in each of the four quadrants? So let's start in the first quadrant. Suppose you have an angle that's terminal side is in the first quadrant. This is my point xy. Okay? For this point xy, is x positive or negative? Well, to plot that point, you go over x and up y. X is positive, y is positive. Remember when we discussed r is always positive. Now, what if we pick this point here in the second quadrant? What could the coordinates of this point be, for example? It'd have to be something like, -7, 5, right? So x is negative and y is positive because you go to the left x and up y. And again, r is positive. In the third quadrant, if you had this point right here, what could the coordinates be? It'd be -something, something. X is negative, y is negative. Again, r is always positive. And the first quadrant, fourth quadrant, what could the coordinates of this be? You go over x, that's positive, and down, so y is negative. Again, r is always positive. Now, you can imagine this picture in your head. You don't really have to draw it out. I'm just explaining my thinking. Right? So notice in the first quadrant, if you take sine, remember sine is opposite over hypotenuse or y over r, cosine's x over r or adjacent over hypotenuse, and tangent is opposite over adjacent or y over x. And you take reciprocals of all those. Notice I'm always taking a positive number divided by a positive number. What does that tell you about the trig functions in the first quadrant? They're all positive, right? Because sine is plus over plus, cosine's plus over plus, tangent's plus over plus, etc. Now let's talk about the second quadrant. Suppose you have a terminal side in the second quadrant. Notice sine, again, I'm using this angle right here. It's sine of this angle, right? It's sine of that angle, but I'm using this to help me. Sine is opposite over hypotenuse, or y over r, positive. Notice cosine is this side over this side, which is negative, and tangent is this side over this side, which is negative. So if you imagine this picture, and you know the definitions of the trig functions, which you need to know very well, you should just know that sine is opposite over hypotenuse, cosine's adjacent over hypotenuse, tangent's opposite over adjacent. You should just be able to spit those out. And you think about this picture in your head, you can figure out where the trig functions are positive and where they're negative. Now, something that's helpful here is every trig function is positive in two quadrants and negative in two quadrants. Now, they're different quadrants depending on which trig function you take. Okay? But you know every trig function's positive in first. So that helps too. Okay? Every trig function's positive in two quadrants and negative in two quadrants, and all trig functions are positive in the first. Okay? So with that in mind, let's do the next example. Identify the quadrant or quadrants, possible quadrants, of an angle theta that satisfies the condition tangent of theta is greater than 0, positive. Now from what I just said, how many answers are there going to be to this? Tangent is positive. I just said every trig function's positive in two quadrants and negative in two quadrants. So I know there are two answers here. And I know one of them without doing any work. Every trig function's positive in the first quadrant. So the first quadrant is one of the answers, okay? You don't have to do anything. Now, we have to figure out where else tangent is positive. Now remember, tangent, another way to think about this, you could just run through the quadrants like I did a second ago, which I will do. But you can also think about tangent is opposite over adjacent. If you want tangent to be positive, both of these numbers have to be, they're either both positive or both negative. Notice that they're both positive, I'm in the first quadrant. right? That's this one. Now, the other possibility is opposite and adjacent. What if they both have negative values? Then you have a negative over a negative, which is a positive. Now, where are opposite and adjacent both negative? That's the third quadrant, right? The opposite and the adjacent are both negative. So the other answer is the third. Or, if you didn't want to think of it this way, just run through them all. Tangent is that over that, positive. Second quadrant, tan is that over that, negative. Tan is that over that, positive. Tan is that over that, negative. Okay, so it's first and third. Okay, you can just kind of run through them like that pretty quickly. Okay, let's see what the next example says. It's a similar problem. It says, do the same thing. Quadrant, a sine of theta is greater than 0, and cosine of theta is less than 0. Identify the quadrant or possible quadrants of an angle that satisfies the both conditions. All right, so we wanted to satisfy both conditions at the same time. Well, let's just do each one separately like we did with the tan. So this is, where is sine of theta positive? I know there are two answers to this because every trig function is positive in two quadrants and negative in two quadrants. And I know sine is positive in the first. There's one of them for sure. Now, if you just run through the quadrants, you can figure out where else sine is positive. So we just did first. Sine is opposite over hypotenuse, or y over r. Opposite hypotenuse. Well, there's plus over plus. There's another plus, second quadrant. Now, frankly, it's a good idea to go ahead and run through the others just as a check. In the third quadrant, sine is negative. In the fourth quadrant, sine is negative. Okay? Because if one of these had been positive, you realize there can't be three of them, and you have to go back and find your mistake. Now let's look at cosine. Cosine less than 0, cosine negative. I know it's not the first quadrant, so there's no point in looking there. And remember, cosine is x over r, or adjacent over hypotenuse. So in the second quadrant, adjacent over hypotenuse. Well, there's a negative. Negative over net positive is negative, so I have an answer in the second quadrant. In the third quadrant, cosine adjacent over hypotenuse, or x over r, that's also negative. So I've got the third quadrant here. Now that should be it, but as a check, let me go to the fourth. X over r, adjacent over hypotenuse, is positive, so it's not the fourth, so those are the two correct answers. So in which quadrant are both of these conditions satisfied simultaneously? The only one they have in common is the second quadrant, so that's the answer. So if sine is positive and cosine is negative, the angle has to be in the second quadrant. Okay, now another problem that's similar to these. It says, give the sines SIG and S of the sine, cosine, and tangent for the angle 298 degrees. So I need sine of 298 degrees, I need cosine of 298 degrees, and I need tangent of 298 degrees. Now, they don't want you to use the calculator here. They want us to use this idea. So I want to know, is sine of 298 degrees positive or negative? Same for cosine, same for tangent. Well, what's the key here? Notice I figured things out, about which trig functions were positive or negative depending upon what quadrant the angle's in. It's not 298 that's important, right? What do we need to know about 298 degrees? Just which quadrant is it in, and we can do exactly what we did before. Now, where is 298? Now, it's not all the way around. All the way around is 360 degrees. And notice halfway is 180, so it's more than halfway. And so 90 plus 90 plus 90 is 270. So 298 is more than that. 298 is in the fourth quadrant. So to answer this question, we just say 298 is in the fourth quadrant. Are sine, cosine, and tangent positive or negative? Well, sine is opposite over hypotenuse, or y over r. So sine is negative. Now we don't just put a negative sign like I did in my picture. We have a symbol for that. Sine 298 is negative, so it's less than 0. And we're in the fourth quadrant, so cosine's x over r, or adjacent over hypotenuse. So cosine is plus over plus, which is positive. And tangent is y over x, or opposite over adjacent, so tangent is negative. So just once you figure out what quadrant 298 is in, you can use this little picture. What if I change this to 300 degrees? What if I put 300, 300, 300? How would the answers change? Well, they wouldn't, because 300 is also in the fourth quadrant. I mean, the sine of 298 degrees and the sine of 300 degrees are two different numbers, but they're both in the fourth quadrant, so both of them will be negative, right? Okay. Okay, so let's shift gears here for a second. The next definition says, A reference angle for theta written theta prime. Now, I'm not going to use the notation theta prime. I don't know that that's standard notation. I'll just say the reference angle for theta. Okay, I'm not going to use theta prime. But just be aware the book is. So a reference angle for theta, which the book is writing theta prime, it's the positive acute angle made by the terminal side of the angle theta with the x-axis. All right, so a reference angle is a positive acute angle, and it's formed between the terminal side of angle theta and the x-axis. Okay, well, let's look, for example, here. Suppose I had theta in the, say, second, well, first, let's do first quadrant. Suppose this was my angle theta in the first quadrant. Okay, now where's the reference angle? Could the reference angle be this angle here that I've drawn in black? Could that be the reference angle of the angle here in the first quadrant? Is that possible? I mean, remember the definition says that it's an angle from the terminal side of theta to the x-axis. So could the angle in black here be the reference angle for the angle that stops here in the first quadrant? And the answer is no. What's the other restriction I didn't take into consideration here? It says the reference angle is positive and acute. This angle's obtuse. It's more than 90 degrees. Okay, so that can't be the reference angle. Where's the reference angle? The reference angle of an angle in the first quadrant is here. Right? Notice it's between the terminal side of theta and the x-axis, and that angle is acute. Okay? This is why I say draw your triangles with a vertical line, because if you do the horizontal line here, the reference angle's here and it's not inside your triangle. Okay, you want the reference angle in the triangle. Well, what if we have an angle in the second quadrant that stops here? Where's the reference angle? It's between the terminal side and the x-axis. It can't be here. That would be obtuse. So it must be here. And likewise in the third quadrant, reference angle is here, and in the fourth quadrant, reference angle is here. So it's that little helper angle that I mentioned earlier. Okay? So whenever you're saying sine of theta, you're doing the opposite adjacent hypotenuse of the reference angle. So it's the angle that's here, 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 or here. Okay? Again, draw your triangles with a vertical line, and the reference angle is inside the triangle. It's the angle in the triangle near the origin, so not these, not those. Okay, so let's do some examples, computations. It says find the reference angle for each of the following. Let me get a clean picture here. So the first example is 140 degrees. It says find the reference angle. Well, I find it helpful to draw a picture. Don't try to memorize, do I add or subtract or whatever. Just draw a picture and you can figure it out. Now, where's 140 degrees? It's more than 90 and less than 180. It's obtuse, so it's in the second quadrant somewhere. You know, I'm just roughly. Okay, so there's 140 degrees. Okay, so there's my triangle. Okay, now where's the reference angle? The reference angle is this angle right here. That's what we need to find. But how do you compute that? Well, halfway around is 180 degrees, and we've used up 140. So to get that angle right there, it's 180 degrees minus 140 degrees, which is 40 degrees. So the reference angle right there is 40 degrees, because 140 plus 40 is 180. So once you draw the picture, you can figure out what you need to do. B is negative 10 pi over 11. Now this is radians, and again, you don't have to convert to degrees. Okay, I would recommend don't convert to degrees, because you're going to waste time converting to degrees, then do the calculation, then have to convert back to radians. Everything in Calc 1 is done in radians, so you need to get used to using radians, okay? So we're going to do this one in radians. Now, let's draw a picture. Where is this angle? So don't think of it as 10 pi over 11. Think of this as minus 10 elevenths pi, right? Think of it as a fraction times pi. Well, where's negative 1 pi? Negative pi radians is halfway around this way. And this is, say, go 10 elevenths of that way. 10 elevenths is almost 1, right? So you're not going to be over here, right? This is, this would be, 5.5 elevenths. Half of 11 would get you to here. This is almost all the 11ths. It's almost negative 1. So that's way over here somewhere. I'm not trying to be that accurate. Right? So there's my angle, negative 10 pi over 11. Now where's the reference angle? The reference angle is this angle right here. I drew my triangle with a vertical line. The reference angle is the angle in the triangle close to the origin. Now, how do we figure this angle out? Okay, well, I'm ignoring the negative here, right? That's halfway around, right? It's negative pi, but just a pi, right? So the reference angle here say pi, and then we've used up 10 pi over 11 of that. Just like we did here, right? Halfway around was 180 degrees. I've used up 140 degrees, so you subtract to get the reference angle, right? All the way to here, again, I'm ignoring the negative, is say pi, and I've used up 10 pi over 11. So if I subtract those, that will be the reference angle. Now here you just have to do some arithmetic, get a common denominator. The common denominator is 11, so I have to multiply the pi by 11 over 11. Right, 11 pi over 11 is 1 pi, minus 10 pi over 11. And 11 pi minus 10 pi is 1 pi. So there's your reference angle. Right, again, you just need to practice. If you want to convert to degrees because you don't want to deal with fractions, you need to do it this way to practice your fractions. You need to know how to do fractions. Okay? Students who are going to take Calc 1 need to understand fractions, so you need to practice. Okay, the third one says 422 degrees, 422 degrees. Okay, well, whenever I'm sketching an angle, one of my first questions I ask myself is the angle more than one complete rotation all the way around? Okay, well, clearly 140 wasn't, and 10 pi over 11, I mean, that's not close to 2 pi, but 422 is more than 360. So I always think of it this way, it's once around is 360, okay, so if I've used up 360, how much more do I have to go? Well, 422 minus 360 is 62 degrees. I have 62 more degrees to go, so that's going to put me somewhere in the first quadrant like this. Right, so again, if I draw my triangle this way, now where's the reference angle here? The reference angle is the angle right here, right, in the triangle next to the origin, right there. Well, how much is that? Well, we figured that out to draw the picture. That's why I think drawing the picture is helpful, because you can do some of the calculations. It may help you as you go. I need this angle right here. We just did that, right? The reference angle here is 422. That was all the way around, and then minus the 360, right, which was 62. So to sketch the graph, I actually computed the reference angle, right? I said 360, how much more do I need to go? 62. But the 62 is the angle in the triangle. So I did the calculation as I did the sketch. Okay, now there's one more. I believe it's in radian mode again. Radian units again, which is 7 pi over 4. 7 pi over 4. Okay, again, the way to think of this, don't think of it as 7 pi over 4, think of it as 7/4 pi. Now, where is that? 7/4 is 1 3/4 pi. So 1 pi is halfway around. That takes care of 1 pi. I still have 3/4 pi to go. Well, pi would take me all the way, another pi takes me all the way around. I need to go 3/4 of the way. If you chop that up into 4 pieces and use 3 of them up, you're going to be here, right? 1, 2, 3, 4, use 3 of them. So there's 7 pi over 4 radians. It's in the fourth quadrant. The reference angle is this angle right here. Well, how do you figure out the reference angle for this angle? All the way around is 2 pi. I've used up 7 pi over 4. So if you subtract those, you'll get the reference angle, right? All the way around is 2 pi. I've used up 7 pi over 4. So if you subtract them, you'll get the angle here. So we need a common denominator again. That's 4. Multiply this by 4 over 4. You get 8 pi over 4 minus 7 pi over 4. 8 pi over 4 is 2 pi. I have a common denominator, so you subtract 8 pi minus 7 pi is pi. So that's the reference angle, pi over 4. So once you draw the pictures, you don't have to memorize, do I subtract, what I subtract from what? Draw the picture and you can figure out all the way around is 2 pi. I've used up 7 pi over 4, so what's left? The difference. Notice here, right, it was all the way around was 360 plus another 62 to get 422. Well, that was the reference angle. So as you're drawing the picture, you can figure out what to do. Okay, now that we know definitions of trig functions for quadrants, for angles and other quadrants besides the first. So this section is all about doing trig functions of non-acute angles like this one. And well, that's more than, notice the reference angle is acute, so it's just like the previous section. But if you're outside the first quadrant, we didn't know how to do those in the last section. But now we do. And we know how to find reference angles too. Okay, let's do some examples. The rest of them have the same flavor now. it says find the exact values for each of the following. So don't use the calculator. The first one says find the cosine of 3 pi over 4. Okay. Well, let's draw a picture of the angle. Okay. So where is 3 pi over 4? Think of that as 3/4 pi. Pi radians is halfway around. 3/4 of that, again, chop this up into 4 pieces and then go 3 of them. Right? 1, 2, 3, 4. That's going to put me here. So there's 3 pi over 4. We draw our triangle, pick a point on the terminal side, not the origin, and draw a vertical line. No problem. Now, to find cosine of 3 pi over 4, we need numbers on the side of the triangle. Notice they didn't give us any of those. We have to figure some out, right? But what's the reference angle here, right? The reference angle is pi minus 3 pi over 4, right? So the reference angle here, we just practiced that, it's pi minus 3 pi over 4. So it's 1 pi minus 3/4 pi, which is 1/4 pi. There's the reference angle, pi over 4. Okay? Now the reference angle is pi over 4, but remember what that was in degrees. Pi over 4 was 45 degrees. Okay? So this is our 45, 45, 90 special triangle. Notice if a problem asks you to find a trig function, cosine of something, sine of something, tan of something, and it says find the exact value, there's only two things we can do, two types of problems like that we can do at this point. If the angles are quadrantal, we can use a unit circle. If the angle has a reference angle of an angle in our special triangles, we can do it without the calculator. That's it. So if I had done this and gotten something like pi over 7, right? That's not 30 degrees, 60 degrees, or 45 degrees. I know I made a mistake, okay? So this is my 45 degree angle. That's 45 degrees. Sorry. What numbers go on the 3 sides of the 45, 45, 90 triangle? It was 1, 1, square root of 2, right? If you can remember the 3 numbers, you can figure out where they go. Root 2 is the largest of the 3. That has to go on the hypotenuse, and the other sides are 1s. Okay. Now, one extra thing you have to do here that we didn't do before is in the previous section with the acute angles and the right triangles, because those were all living basically in the first quadrant. We're in the second quadrant here. Don't forget to check to see if any of these numbers need to be negative. In the second quadrant, x is negative, right? It's negative 1, 1. That's the coordinates of that point, minus 1, 1. Remember, r is never negative here. Don't forget to check for negatives. That's a common mistake. Now, couldn't we find all 6 trig functions here? Sure, right? There's nothing special about cosine. We have all 3 sides. We could do all 6. But it only asks for one of them. So the cosine, definition of cosine is either x over r or adjacent over hypotenuse. So using the little reference angle here, the adjacent side is minus 1. The hypotenuse is root 2. So it's minus 1 over root 2. Or again, x over r, however you learned them. Okay, so that's that one. The next one says cosecant of negative 120 degrees. Again, it says find the exact value. So we're not using the calculator here. Let's draw a picture of negative 120 degrees. Negative 180 is halfway around, so it's not quite halfway, but it's more rotation than the 90 here. So it's going to be something like this. So there's negative 120 degrees. Pick a point on the terminal side, make your right triangle with a vertical line. Okay, now what's the next step? Remember, math is all about memorizing what steps to do. Okay, so what's the next step here? I sketched the angle. Now what do we do? What did we do next in the previous problem? Well, we found the reference angle. Okay, so halfway around is 180 degrees. We've just used up 120 of that, so the reference angle is 60. That should not surprise you, right? Because if we're going to do one of these problems without the calculator and give the exact value, it's special triangles or quadrantals. So as soon as I see this is not a quadrantal, I know my triangle is going to be the 30, 60, 90 or the 45, 45, 90. It has to be. If it helps, you can put the 30 down here. But be careful, that's not the angle we're using, right? The reference angle's here, 60. Now, what were the 3 numbers on the 30, 60, 90 triangle? It was 1, 2, square root of 3. So the 45, 45, 90 is 1, 1, square root of 2. The 30, 60, 90 is 1, 2, square root of 3. If you can just remember the numbers, you can figure out where they go. of 1, 2, and root 3, 2 is the largest. So 2 has to be on the hypotenuse. Of the 1 and the root 3, 1 is the smaller of the two. The smallest side is opposite the smallest angle. So the 1 is opposite the 30, which means root 3 here. Notice how I do these. I say, what's the biggest number? Put it on the hypotenuse. What's the smallest number? Put it opposite the smallest angle. Now in this one, the two sides are the same length. Right? So the 1 is opposite the 30 because 30 is the smallest angle, 1's the smallest side. Now don't forget to check for negatives. In the third quadrant, x and y are both negative. Remember, r is never negative. Now that I have my triangle on the three sides, you could do all 6 trig functions, but they only ask for 1. Now what was the definition of cosecant? Again, either x, y's, and r's are opposite adjacent hypotenuse. It doesn't matter which way you memorized it. Cosecant is the hypotenuse over the opposite, which is r over y. So it's 2 over negative root 3. Again, the book or the online homework would want you to rationalize. Okay, there's 2 more like this. The next one says tangent of 3 pi over 2. Tangent of 3 pi over 2. Okay, let's sketch the angle. This is in radian measure. So think of 3 pi over 2 as 3/2 pi. So I'm really thinking of this as 3/2 pi. But 3/2 is 1.5. Now where's 1.5 pi? Well, 1 pi is halfway around. That uses up the 1 pi. I have half pi to go. That's half of around. That takes me to here. Okay? Now, how is this problem different from the ones we just did? I've landed on an axis, right? That makes this a quadrantal angle. And when you do trig functions of quadrantal angles, you do not draw a triangle picture. Don't try to make a triangle out of this. It's a quadrantal. We stopped on an axis. All right, for non-quadrantals, it's a triangle picture. For quadrantals, we're going to use a unit circle. Remember that section a couple sections ago. So imagine the unit circle. I'm going to pick the point on the terminal side that's 1 unit away. It's on the unit circle, so this is going to have the coordinates 0, -1. Right? For quadrantals, that's how we're doing it, right? You can use the unit circle for anything, but remember the quadrantals are easy to pick the point that's 1 unit away, right? Remember, if I have the unit circle and I just say, oh, here's 110 degrees is here, what point is that? I have no idea. Okay, so the quadrantals are easy. That's 0, 1, -1, 0, 0, -1, 1, 0. Okay, so I'm always using unit circle just for the quadrantals. All the others are triangle pictures. Okay, now how do you get tangent from the unit circle? Well, remember tangent was y over x. Now if you learn x, y, and r, in this section, x, y, and r, you can use that even for quadrantals. Remember in the unit circle section, we said tangent was y over x. That's exactly what it says tangent is in this section. Now you can't use opposite adjacent hypotenuse here. That's not going to help you. But, okay, suppose you learned the definitions opposite adjacent hypotenuse. Right, here's x, here's y, that's r. That's no problem, right? X, y, and r. So if you learned tangent is opposite over adjacent, just use this picture. Opposite over adjacent is y over x. Y over x. Okay? So use this picture. So if you learned opposite adjacent hypotenuse, you can go to x, y's, and r's. Or if you learned x, y's, and r's, suppose you knew cosine was x over r. Just think of this picture. Cosine's x over r. Oh, well, that's adjacent over hypotenuse. So you can translate from one way to the other, however you memorize. Okay? All right, so here you can say tangent is opposite over adjacent. That's y over x. Y over x. So you can actually use that on the unit circle, what I just did. So this is -1 divided by 0. Don't even write that down because that's undefined. You can't divide by 0. So I threw this one in here in this little section here to remind you, if it's a triangle picture, you do it one way. If it's a quadrantal, you do it another way. Don't do it with triangles. Okay, and then the last one here says sine of 405 degrees. Right? Why don't you pause the video and see if you can do this problem from beginning to end, and then I will do it. We'll see if we get the same thing. Okay, so let's work this one out. So I want to sketch the angle 405 degrees. Well, that's more than once around. So all the way around is 360. Now how much more do I have to go to get to 405? 405 minus 360 is 45 degrees. So that puts me halfway through the first quadrant. And there's my triangle picture. And we just figured out the reference angle in our calculation is 45 degrees. All right, so this is our little special triangle. What are the three numbers on the 45, 45, 90 triangle? 1, 1, square root of 2. Square root of 2 is the largest number. It's on the hypotenuse. And the other sides are both 1s. Now don't forget to check for negatives. We're in the first quadrant, so x and y are both positive, so that doesn't apply here. Okay? And now all we have to do is answer the question, what's the sine of 405 degrees? Well, sine, again, it's opposite the reference angle. Sine is opposite over hypotenuse. It's 1 over root 2. Or if you prefer, y over r. Very easy. So it took some work to calculate the reference angle, but then once you have the reference angle, it's a special triangle, and it works just like the ones we did before. Okay. So notice in all these problems we've been doing here, they gave us the angle and said find the trig function values. That's not the only type of problem, right? They gave us the angle and you found the trig function values. There are other variations where they give you information where you can, it's enough information to draw the picture of the triangle. And that's what these last two are about. So the problem, it gives me the following information. Sine of theta is negative 3/5, and theta is in the fourth quadrant. Okay? So sine of theta is minus 3/5, theta's in the fourth quadrant, and they're interested in finding cosine theta. Now, in the book, for this problem, the instructions say use a trigonometric identity to find the answer. I'm not going to do it that way. Remember, we had a Pythagorean identity, sine squared theta plus cosine squared theta equals 1. Notice they gave you sine, and they were asking for cosine, so they want you to use that identity that had sine and cosine in it. But, what if they gave you sine and they asked for tangent? There's not a Pythagorean identity that has sine and tangent, in the same one, so you couldn't do it that way. So that's why I'm going to just draw pictures like we've been doing to get the answer. Now, I think they want you to do it that way to practice using those Pythagorean identities, but I don't think it's worth the effort. I think it's too much trouble. So I'm just going to draw the pictures like we've been doing and get the answers. Plus, once you have the triangle picture and the three sides, you could do all 6 trig functions, not just the one. Okay, so that's why I put in the notes here. I'm going to do it just drawing pictures. Well, they told me theta's in the fourth quadrant, right? So I don't know that this is the rotation. I just like to put rotation on my pictures. So there's a possible picture for theta. Theta is in the fourth quadrant. I don't know the scale. I just put it in the fourth quadrant. Now notice, I don't know theta, so I can't figure out the reference angle. Okay, and if the reference angle was 30, 60, or 45 degrees, I could put my numbers on the triangle. They didn't give me any of that. But what did they give me? They told me sine was negative 3/5. So just think, ignore the negative for a second. Just think of that. Sine is what over what? It's opposite over hypotenuse, or y over r. So use this as the opposite and use the 5 as the hypotenuse. So there's 3 and there's 5. Okay? So just use the numbers in the trig function sine. Now, if they give you an integer, for example, if they said tan of theta was 6, and you were trying to do this, just think of 6 as 6 over 1. Write it as a fraction. Even if it was a decimal, right? If they gave you tan of theta is 0.234, and you were trying to do the same thing, just put 0.234 over 1. Now you've got your two sides. Okay? Okay, now we need the other side. And I have to go back and look at the negative, but I need the other side. Just use Pythagorean theorem. It makes sense to call that x. X squared plus 3 squared is 5 squared. The length of the leg square plus the length of the leg square is length of the hypotenuse square. So x squared plus 9 is 25. X squared is 16, and x is 4. Now again, x is really plus or minus 4, but in the first quadrant, x is positive. Now what about this negative 3/5, right? The reason why is the negative could be on the 3 or it could be on the 5. So I just ignored it to put the numbers in. But if you look at your picture, what needs to be negative? The 3. I said first quadrant here. Sorry, we're in the fourth quadrant. X is positive and y is negative. R is always positive, so the negative here is on the 3. And you can certainly check, right? Look at my picture. Sine is negative 3 over 5, which is that. And this is called a Pythagorean triple. It's not special triangle. This is not a 45, 45, 90. Well, how do you know it's not a 45, 45, 90? The two legs aren't the same. How do you know it's not the 30, 60, 90? Remember, the 30, 60, 90 two of the sides were 1 and 2, right? The short side was 1, the hypotenuse was 2. The hypotenuse is always double the short side. The hypotenuse is not double one of those sides, so it can't be the 3069. So it's not a special triangle, but this is a Pythagorean triple. 3 squared plus 4 squared is 5 squared. This triangle shows up all the time in these trig books and pre-calc books. That's just one you probably want to memorize, 3, 4, 5. But just be careful, right? Just because you see two of them doesn't mean the other one's the third. For example, if that's a 3 and that's a 5, that's not 4. The hypotenuse can't be shorter than a leg, okay? So if you're doing 3, 4, 5, the 5 has to be on the hypotenuse. And remember, we did another problem the other day. Remember that Pythagorean triple was 5, 12, 13. 5 squared plus 12 squared is 13 squared. Those two show up all the time in these books. Okay, so back to the problem. We could do all 6 trig functions now, which is why I like this method rather than doing identities. But they only ask for cosine. Cosine's x over r, or adjacent over hypotenuse. Cosines are like this. But notice you could do all 6. That's why I like this better. Okay, so they didn't give us an angle. We couldn't find the reference angle, but they gave us one trig function value that gave us 2 sides of the triangle. And now the last one is very similar. It's the exact same idea. And it says, suppose secant theta is minus 9/4, and suppose theta is in the third quadrant. And they want us to find tangent of theta. Notice again, in this problem, they want you to use identities. There is a Pythagorean identity that has secant and tan, both of them. 1 plus tangent squared theta, secant squared theta. That's what they want you to use. Again, I'm going to do it by drawing pictures. Why don't you pause the video again and see if you can draw the triangle picture for this particular problem. Okay, so they told me theta was in the third quadrant. Again, I don't know that that's rotation. I just like to put something in. So there's theta. And I don't know theta. I can't find the reference angle, but they told me the secant was negative 9/4. Okay, ignore the negative for a second. Secant is what over what? Well, secant is hypotenuse over adjacent. So the 9 needs to go on the hypotenuse, and the adjacent is the 4. Now the negative has to go on one of those. It can't be the hypotenuse, so it must be on the 4. Or once again, think in the third quadrant, x is negative. Now we need to figure out this other side. Use Pythagorean theorem. Again, I'm going to ignore the negative because I'm going to square it anyway. So 4 squared plus y squared is 9 squared. So that side squared plus that side squared is that side squared. I'm calling this y. So 16 plus y squared is 81. So y squared, 81 minus 16 is 65. And so if you take the square root, you're going to get y squared is 65. Now be careful, it really is plus or minus. Notice I'm in the third quadrant, so y is really going to be negative. It's not the positive square root, it's the negative. Always at the end, look at your picture and make sure you have negatives everywhere in you. R is never negative, and in the third quadrant, x and y are both negative. Okay, so it's a common mistake to drop a negative, so make sure you check that. And now, we could do all 6 trig functions if we wanted to, but they only ask for tangent, which is y over x, or opposite over adjacent. The negatives cancel out, and you get square root of 65 over 4. Again, normally I would ask for the exact value, so I wouldn't want you to punch that in around. Okay, so that'll get you through section 4.4.